Hi, welcome back to my channel. Today we've got a 2008 Dodge Avenger, and the complaint is the right turn signal blinks quickly, and I don't think the right front's working. So I checked all the lights on the car, and the only thing not working is the right parking light and the right turn signal. It's the same bulb, so we're going to check that out. Hang around. That's our verification of the complaint. So we're going to take the light bulb out, or at least the socket out, and we'll go from there. I put a light back here. This thing lives, I don't know if I can get it in there, all the way down under here. So if you give me a second, I'll pull that out. There it is. Now, I know it's blinking, but it's blinking fast. And it's also using the wrong filament of that bulb. So tonight we're just going to do a real quick voltage drop test of this particular circuit. And I'm going to use some pretty simple stuff. This is a $9 meter from AutoZone. And I bought this once, probably about 8-9 years ago in an emergency situation, just to get back on the road. But I'm showing this because you don't need all the fancy tools to do what I'm about to do. And then might be using a test light. So I'm going to set up this test. We're going to do a voltage drop test on this and see what's going on. I've got my meter hooked up with a pair of vice grips. There are no clamps with this meter. It was $9. To the negative battery post. I can't get to the battery, it's under the fender. This is going to be close enough. So we're going to use the 20 volt scale. And you can see, I'm going to take the red lead and I'm going to touch it to the battery cable just to test my meter. So we're good, we got a connection. I am going to cheat. I'm going to use a back probe. You can use a T-pin. You can go to the sewing place, go to Walmart and get T-pins. I had a couple of different sizes. I normally have those around here, but for some reason I can't find one, so I'm going to get this. So what we're going to do is we're going to get this light bulb. We got 3 wires here. I'm also going to turn the lights on. Hang on. I've turned the parking lights on and the bulb has quit flashing. I probably know what's going on here already, but I'm going to do this demonstration and show you what we've got going on. Then I'm going to explain to how this works. Okay, I've got the first white wire, doesn't matter, hooked up, back probed, and I'm going to see what we got. We've got a steady battery voltage, keys on, battery's going down. So I would say our power is good for the light. Let's try the turn signal. So we'll just take this out of here, slide it gently into here, into the second white wire. They've got other colors too. And we got battery voltage. It really should be blinking, but it's not. So now we're going to check the ground. Now I've got the ground wire of the meter hooked to the negative post, basically, of the battery, the ground. So let's hook this up to the ground. Remember to be gentle doing this. There we are, hooked into the ground. So let's see what we got there. We got 11.5 volts on the ground. How could that possibly be? Why do we have power on the ground? Let me explain. Welcome to my cardboard. Well, let me tell you what's going on here. Let me explain. This is a simple electrical circuit. We have a switch, we have a light bulb, and we have the wiring from the positive and then wiring to the ground. Very simple. There's a fuse in here and other things, but this is all we need. So we're going to explain what happens here. So if we want this light bulb to light, we close the switch and complete the circuit. So the electricity flows from the battery in this direction from the positive cable through the switch into the light, into the little filament that's supposed to light up. And then it travels through this filament, and this filament has resistance. So the voltage uses this resistance, and then the light lights up because the voltage comes down through the ground. It travels back up into the negative cable, and that completes the circuit, causing the light to work. That's how it's supposed to work. Very simple explanation. So, but what we have is we have the battery, positive, negative. Let's just draw it with the switch closed because that's what we have. Okay, and then the light bulb. And then back to the battery. So with our voltmeter, at the light bulb right here, we're measuring 12 volts. Well, we have battery voltage, it's a little bit lower, 12 volts. But for some reason, we are measuring 12 volts here. Why? Well, how can that possibly be? If you took your meter and went from here to here, do you think we'd have 12 volts? I mean, on a regular working system up here on this one? No. Let me tell you what would happen. We would have 0 volts, or pretty darn close. Not exactly 0. And that's because in this example, the electricity comes down positive, although that's up for debate, through the light bulb. The light bulb uses this 12 volts, and there's nothing left on this side. And it completes the circuit back to the battery. So this light bulb, which is the load, should use up all the 12 volts in the system. If it's not using up all the 12 volts in the system, then there is something wrong on this side. So, in our example, we have 12 volts on this side. In this example, it would be 12 volts. And all that voltage gets used up through here. And then there should be nothing left coming out. It should be 0. In our example, we have 12 and 12. So what that tells me is this. Not only is the power source to the light bulb good, the filament in the light bulb is good, but something's going on this ground. And we're going to explain what that is the best I can. Anyways, I'm not much of a teacher, I guess. So to make this shorter, here's what's happened. Somewhere in this wire, between the black wire on the light bulb and the battery ground, there's something happened. Either the wire is open, which means the wire is broken. So the wire would look like this. That would be what your circuit looks like. So that's why we still have 12 volts. It goes through here, through the filament. And it's not using any resistance because the 12 volts isn't making it back to the battery because we have this open. So somewhere between here and here, there's an open wire. And we found that with one simple test, which was using the voltmeter. Now, to find this open, we would have to start here with our voltmeter and work our way back, and we would have 0 volts or 12 volts all the way to this point. And once we crossed over that open, we would have 0 volts. Not because it's being used up, but because there's nothing connected to this side. So what we have here is a bad ground. Something's wrong with the ground. And I'm going to look at some wiring diagrams and see where this ground is. And then we'll think about a repair. Now this car has like 180,000 miles or something on it, and it's 2008. So we're going to base the repair on that. I don't know, this probably wasn't a very good thing, good example, but if we had this same circuit and we had the 12 volts going to the light bulb, the filament, and then let's just say we had some corrosion. All right? We would find that the same way. Let's say that this is lit just a wee little bit, not very bright. It might be blinking fast and blinking at a dim pace. So at this point, we would have our 12 volts. No, we would have the amount that the load was using might be, depends on how much this corrosion is. Well, let's just make it easy. Let's just say it's the same resistance as this light bulb. So we're going to have 6 volts. And then that 6 volts is going to come out, and it's going to be here. And it's going to be all the way to here, to the first part of the corrosion. Or the resistance. Because this light bulb wants all these 12 volts. It needs it. To light it up like it is up here, it needs all 12 volts. But if somebody else on the ground is also resistance, it's going to take what it needs too. So if this was the same resistance as a light bulb, this is just to make it simple. This would have 6 volts here, and when we got to the other side of the resistance, there'd be 0 volts. So, that would be an indication of high resistance. If you had, it could be any number too. It could be 8 volts, 4 volts. That has to add up to the 12 volts we have here. So if you saw on your ground wire anything other than 0, I mean a good number on a little tiny wire like this would be like 0.3. I wouldn't be chasing that. But anything over that, like a volt or 2 volts on this ground wire, I'd be looking for it because that's bad. So right now we have to find where the open is. Although I don't know how far we're going to go, we're going to find out where this ground is and go from there. Okay, so here's our diagram. Now I'm using Mitchell On Demand, but if you are a do-it-yourselfer, you can get Mitchell do-it-yourself for whatever car you're working on, your car or somebody else's car, anything like that, for $20 a month, or if you were going to keep your car for a while, $20 for 1 month. I think a 4-year plan for one car, I think it's $40. I mean, that's a bargain. It has, not only does it have wiring diagrams, it will have everything you need to fix your car, look at your car, diagnose your car for $40 for 4 years. That's a bargain. So let's look at what we have here. This is our right turn lamp, and this is our ground wire. Now it's just a single wire going over to this ground here, and it says it's on the right shock tower. That's pretty simple. Let's take a look. Right there it is. So, although I can't see anything wrong with the ground or the wires there, on this car, I'm not going to look for this bad wire. It's not showing any splices or anything. This only works the right lamp. So what I'm going to do is I'm going to make a little splice right here in the black wire. I'm going to solder it and heat shrink it. I'm going to run the wire back around the coolant bottle, and I'm going to put, where'd it go? I'm going to put this on it. However, I'm not using this part of it. I'll be taking the plastic off, crimping the wire, and then putting a dab of solder on it and putting some shrink tube on it. Now, do I need shrink tube on this ground? Probably not. It's just the way that I like to do it. You can buy these rings without the plastic, and you don't have to do that. You can crimp it, and this one actually is a shrinky dink crimp, which means if you heat this, it'll shrink and seal. But I'm going to crimp and solder it, and then I'm going to run the wire around, and we'll splice in here. Let's get started on that. There it is, crimped and soldered. Now, we'll just slide that shrink tube up on there. And we will shrink that down. A little bit of glue coming out there. All right, that end's done. All right. Where'd it go? I lost it. There it is. All finished, ready to install that part. All right, now we'll do the splice. So I've removed the pin from the connector. I've stripped back a small piece of the insulation, and I've made a little V, well, a little hole in the wires. What I'm going to do is I'm going to stick this in here, like so. And then I'm going to wrap it around this wire and solder it. And I'm going to show you the steps. I really just can't do both. That's it, all wrapped up. I'm going to put a piece of heat shrink on it, a little bit of solder, and a little bit of shrink tube. Okay, there's the sealant's coming out on both ends. Okay, we're going to put this back together as soon as it cools. All right, we've got the ground wire. You can see it there underneath that ground 105, G105. And we have success. I know it's hard to see, but both lights are working, the parking light and the turn signal light, and it's going at a good speed. I'm going to call that a fix. Maybe a little better view. Okay, everybody. Thanks for watching. That was a long one for a light out, wasn't it? I really I don't know that I did a very good job of this. I know this stuff inside and out, but I've got to figure out a way to share it better. So honestly, if you have any questions about any of this, I am more than willing to answer them in the comments. And I hope you got something out of this. Could we have used a test light and checked the power and the ground separately? Yes. Sometime my light calibrated eye, if I can tell if it's brighter or not brighter, isn't as good as a meter. And like I said, I did use the little Innova meter, which I got at AutoZone probably, I don't know, it's been years. It might even be 10 years ago, and it's probably got the same battery in it. But it's just, I used it to show you that you don't need the expensive stuff for a lot of this stuff. And I'm gonna do more than that. The test light would have been, probably would have worked the same way. We probably wouldn't have lit up on the ground if we had put the test light to positive. You could have done it that way, but I don't know. I like to do the voltage drop. It's easy, it's quick, and it's definite. If you need more explanation, ask me a question in the comments. I'll do my best to answer you. I may be better at answering you that way than actually talking about it. So, hey, well, thank you for watching. Remember to like, subscribe, and hey, ring that bell. Make a comment, anything you want to do. Thanks again. Have a good night.